In this video, we will learn how to find out the optimum quantity of labor from the given production function. The question is, the production function of a firm is x is equal to 5k to the power 1 upon 2 times L to the power 1 upon 2. X denotes the output, k is the units of capital, and L denotes the units of labor. We are being given that units of capital is 16 and price of output, that means price of x, is 6, and wage rate is being given us as 5 per unit. We have to find out the optimum quantity of labor. The options are 140, 140, 144, and 148. We need to choose out the correct option. Okay, so how do we solve this kind of question? Let us write the production function, that is x is equal to 5k to the power 1 upon 2 L to the power 1 upon 2. Also, we are being given k is equal to 16, price of output is equal to 6, and W is equal to 5. Okay, we need to find out the optimum units of labor. Okay, so first thing is, what will we do? We simply plug k is equal to 16 in this production function. That means x is equal to 5 16. So we have 16 raised power 1 upon 2 times L to the power 1 upon 2. Okay, 16 raised power 1 upon 2 is 4, so our x will be equal to 5 4s are 20 L to the power 1 upon 2. Okay, now what will we do? First, we need to find out the total revenue. By total revenue, and how do we find out the total revenue? So total revenue is simply equal to price of output, that is px, into x. Okay, so price of output is being given as a 6, so I can write 6. X is this very production function, that is 6 into 20 L to the power 1 upon 2. So our total revenue is equal to 6 2s are 12, that is 120 L to the power 1 upon 2. Okay, also we need to find out the total cost. And what will be the total cost here? Total cost for the firm will be simply the wage rate times units of labor. Okay, that means total cost is simply wage rate is being given us as 5 times L. Okay, now profit maximizing condition for monopolist is, so what will be the profit maximizing condition for monopolist? He will equate his marginal revenue with marginal cost. Okay, that means we need to find out the marginal revenue and marginal cost. Total revenue is here given, so from total revenue we can find out marginal revenue by simply differentiating total revenue function with respect to labor here. Okay, so differentiating this function with respect to L, derivative of L to the power 1 upon 2 is, so if we have L to the power 1 upon 2, its derivative is simply exponent becomes coefficient and exponent is subtracted by 1. I have explained it number of times, so we will get here 120 times 1 upon 2 L to the power 1 upon 2 minus 1 is minus 1 upon 2. So this gives us 60 L to the power minus 1 upon 2. This is our marginal revenue. Okay, so also let us find out marginal cost. Marginal cost is simply the derivative of total cost function with respect to labor. Total cost function is this, derivative of L is 1, so we are left with 5. Now equate marginal revenue with marginal cost, okay, to get the optimum units of labor. Marginal revenue we got is 60 L to the power minus 1 upon 2 is equal to marginal cost is 5. Okay, so we can do one thing here. I can write it in this fashion: 60 divided by, if I transpose it to denominator, exponent sign will become positive, it is negative, it becomes positive, is equal to 5, which implies okay, what can we do now? Okay, let me see. So we have here, let us cross multiply here, so that means 5 L to the power 1 upon 2 is equal to 60, or L to the power 1 upon 2 is dividing both sides by 5. So 60 divided by 5 is 12, or L is equal to, if I transpose exponent to RHS, it will become exponent, but it will get reciprocated. So it will become 12. If it is 1 upon 2, it will become 2 upon 1. Okay, so we write simply 2. That means L will be equal to 12. 12 are 144. That will be the optimum units of labor required. So the correct option should be C option.